Alright, welcome back. We are COMP397 in the winter 2020 semester, and it's week 12, part 1 of our broadcast, Intro to Particle Systems with Create.js. Alright, so let's talk about a couple of things. First of all, I've given you a couple of files in your eCentennial. So if you go to eCentennial here, you'll see that there's a particle system.zip file. I want you to download that. We're going to use this one when we create our project today. Okay, so it's kind of an important thing to use. I'm going to start off with the project that we were working with last week, right? So we're going to go into our desktop, and we're going to look at COMP397, and there was a project last week, 11C. We're just going to copy that and paste it. And 11C will turn into 12C, like we've done before. There's 12C. All right, cool. And now we're going to bring up VS Code as normal. And what we're going to do is we're going to drag and drop this in here. There we go. And we need to make some modifications before we put this off. So a couple things, like we normally do, is control backtick. We're going to say git remote remove origin. And if you wait a second, for those people who are waiting to download this, just wait while I put this up on GitHub, and you can download the whole GitHub project. Okay. And then what I want to do before I put it up on GitHub is do a couple of things. One, our package.json should say 12C and less than 12, which is what I'm doing here. And that's done. And then I want to add in those files that we're missing. So I kind of put in 2 files. So let's just go back in there, and we can lower this one. Go back in there and talk about those 2 files. So I have 12C, I have inside there. So we have scripts. Inside scripts we have objects. So there's some stuff we're going to put in here. So let's, if you unzip the files, if you want to do this manually yourself, you can, or you just can wait for me. So in the objects section, I have a particle emitter and a particle that I want to just kind of copy paste. So I want to get these 2 things. I want to cut them from here, and then I want to paste them in here. So that's particle emitter and particle.ts. Emitter and particle. Okay, and then inside of the enums folder, I have 2 enumerations that I want to grab. One of them is called Emission Shape, and the other one is Particle Shape. So I'm going to cut those 2 out and put it in here. So those are the 2 I have in there, Particle Shape and Emission Shape. Again, you can wait for me to do this, and I'll put this up on GitHub in a second. You can download the whole GitHub project, might be the best thing to do. But I separated them, so online, if you wanted to build this by yourself, later on you can totally do that. Alright, so under scripts now, you can see I have extra scripts, particle, emitter, and particle. I'll talk about those. And under enums, a couple of new enumerations. And I'm going to Control-Shift-B to build them. I haven't put it up on GitHub yet, but I want to build them first, so then you have everything. So it's going to create the additional files we need. Right, so there's like 13 files just made. And now is a good time to put it up on GitHub. So I'm going to go here, and I'm going to go up to GitHub with a new tab. Sorry, I got to move all the stuff you can't see around, so bear with me while I do that. So we'll say github.com, and then of course you want not me but Centennial, and I want a new project. So this is going to be COMP397 in the winter 2020 semester, and it's lesson 12C. Okay, and we're going to get some steering directions from GitHub, these 2 things. And I'm going to go back to here, Visual Studio. No, not that Visual Studio. That's Visual Studio. I want it to go to Visual Studio Code and right click. There we go. Alright, so now I can just take this and put this out of the way again. So that way you don't have to watch me do this. Okay, cool. So then what I have now is a couple things. I have this emission shape and everything else. I'm going to put this up on GitHub. So I'm going to go to here and I'm going to say added particle and particle emitter. Okay, so add all those to the staging area and then push this up on GitHub for you guys. You guys get the added value of having this up without the pain of watching me put it together like the other class did. I bit off a little bit more than I can chew today by trying to do this in class. It was too much. Okay, so let's take a look at what we currently have. Again, we have a watch task, but I want to run light server. So let's see if this still runs. Yes, it does. However, in order for us to make our stuff work in our index.html, we need to add several files. Remember, because until we add them in, they're not available to us. So under enums, let's add those changes in. So script, this is something that if you wait again, I'll do it for you and I'll put this up on GitHub. Script source /scripts /enums / again, what we want is the particle shape. And we also want the emitter shape. So script source /scripts /enums and then /emitter shape.js. Okay, so emission shape as well as the particle shape. We'll talk about those two things. And then under objects, they really don't depend on anything other than themselves. So first the particle itself. So script source and then /scripts /objects /particle and then script source /scripts /objects /particle emitter. Alright, so we got all that in there, and now let's start. I'll put this up on GitHub, so I'll say updated index.html to include particle and particle emitter. Yeah, okay, I know I'm over. That's okay this time around. Let's also add this to staging area and push. So you should have that update as well. Now you can download from GitHub. Now it's ready to go. This is our starting position. Okay, so I'll wait for you to do that. And let me know if you guys are ready to go with that, as we're going to start with that. Also, to make this a little better, what I'm going to do is I'm going to stop my video so that way it's a little bit more performant. Otherwise, there's too much video going on. Video and then YouTube and everything else, it's like a lot. All right, are you with me? Have you constructed everything, or are you downloading from GitHub? What are you doing? I'm getting a sense that you're ready to go. Yes? No? Somebody? All right, so by now either you've downloaded it from GitHub or you constructed it yourself. But more or less what we want to do is take a look at the stuff I just gave you. So under objects, let's take a look at my particle first. So here's particle. So what is the particle class? So think about a particle as like a, what would we use particles for, by the way? There's particles, and for people who are not game developers, there's particle emitters and there's particle systems. So particles are a single shape. It can be both a bitmap, some kind of image. We're not going to do a bitmap here today. We could also make it an actual shape that we can draw, which is what we've done, a particle shape. And then a particle emitter is a container that can hold a bunch of particles, right? So let's say, for example, 100 particles or 500 particles, right? That kind of thing. And so that's a single emitter. And then an emitter system, a particle system, is a series of emitters. Okay, so example would be, I want to make a magic portal, right? And in order for me to make a magic portal, I need several particle systems. Maybe one for smoke, another one for fire, another one for the ring, and so on. There's a bunch of different things we can do here. And then each particle emitter inside the particle system is going to have a bunch of particles. Particles meaning little objects that appear on the screen, okay? Sometimes they're very small, like points. Other times they have a shape, like what I'm giving you, right? And what this does, it creates very interesting effects for your games. One of the effects could be a dust trail. You could also have some kind of explosion, or, like I said, smoke and fire. Sometimes it's just an interesting, you know, when you pick up an item or you drop an item, there's a little sparkle. All those sparkling things that happen, they're all done a lot of times with particle systems. And with Create.js and Easel.js, there is no built-in particle system. It doesn't exist, okay? Instead, we have to make it on our own. Okay, so that's how it goes. So we start with the building blocks, and the first building block is this idea of a particle, the first thing. So a particle is made up of, first of all, it extends, and originally I had this extend the create.js.displayObject, and the display object itself contained a shape, okay? But now I just made it extend the create.js.shape. So what is create.js.shape? Well, let's take a look at our documentation here for a second. So the shape class, here it is, the shape class. So what it is it consists of two things. A shape, it contains a graphics object. A graphics object is a low-level object that allows us to draw a circle or a square or a rectangle or an ellipse. We could draw physically, you know, like manually, if you will. We manually construct a shape through code. And what that means is if I want to make a hexagon, then I give instructions to the computer, to our API, or application programming interface, to make a hexagon. Okay, so that's what a shape is. A shape consists of a graphics object. So there's two ways you can construct a shape. One, you make a graphics object first, and you tell it to do things like, hey, I need to begin a fill of and this is RGB, a red color. I want to make a red fill, and I want to fill up a rectangle that starts at 0, 0, and it has a width and height of 100, 100. So this is actually a square. A red square is what I'm making, right? And then after I make the red square through this graphics object, I pass the graphics object to the constructor of the shape. And then I can add the shape to the stage. So the shape gives me the transform components, X and Y coordinates and all that stuff. The graphics object is me creating or rasterizing a shape by code. So I make my shape, and then I add that shape into as a graphic inside the shape constructor. That's what I'm doing. So that's one way of doing it. The other way of doing it is, let's suppose I don't have a graphic yet. First I make my empty shape, and then I update my graphics object with the same data. I can do it either one way or the other. This is both acceptable. Okay? So that's how it works. And then in order for me to see whatever I made, I need to add my shape to the stage somehow, or to the container that is being drawn. Okay, that's what happens. So if knowing this, then if I go back to this, I have my particle, which is a shape. Okay, particle is a shape. Particle is not a display object. It is a shape, which means I have the ability. It contains a graphic object by itself. But we're going to give it some configuration. One is we're going to give it velocity and acceleration and force and mass If we want to do any kind of physics calculations with each particle, I can do that. I can make it so that they're attracted to something or repelled by something. They might be following a path. All this stuff is something that we can do with each of these particles. They also are going to have a initial size, and they're going to have ranges. So a beginning size and an ending size. And a good example of this is maybe our fire starts with a small size, right? But then later on the smoke becomes bigger, right? It kind of billows out, right? So the particles can actually become bigger, right? We can also limit our speed. We can start with the beginning and we can go to the end. So they can get faster and faster or slower and slower. We also will have a life for the particle. How long in seconds does the particle last? And a lifespan. We can also have color, but I've excluded color for now. We're just making them all black, just for now, okay? We'll start with black and see how far we get today. And then shape width and height. So this is the width and height of our shape, as well as any kind of filters. This is for color. We're not going to use color yet, so this is just in there for us. If I had to add a graphics class, it would be like this. I would make my own graphics, but however, graphics is included, so I don't need this graphics class. Graphics is part of the shape class, so it has that. Okay, my type. I'm going to be talking about each particle has its own shape, and I have a particle shape enumeration that I made. That's why you put those enumerations in there. So there's different shapes. The particle can be a circle, a square, a triangle, a hexagon, a star, and you can make your own shapes as well. Okay, whatever shape you want. That is one of these if you want to. Okay. And of course, we're getting an emergency alert at the same time. Stop the spread of COVID-19. It's gonna be deadly. Stay home. I recently saw the Samuel L. Jackson nursery rhyme where he says, "Stay the home," right? And it was a really, actually a good one. He does these nursery rhymes from time to time, and they're kind of interesting. You should look it up. Anyways, so let's continue. So we have this particle shape, and the particle shape can be one of those, right? In the constructor function, we can set the particle shape to be whatever we want, and the default size. Now this is in pixels. 50 pixels is quite large. Okay, to let you know, like that's a, usually it's pretty big. And then what we can say is we want the size, this size, to be the size of the number we pass in. We make an initialize function. This initialize function initializes a bunch of different things. One is, first we're going to make the graphics object. So what we do is we make the graphics object become clear. We set the stroke size, stroke style to 1, which is the thickness number. So the stroke around the particle. We also make the stroke itself black, but we can have a stroke color and a stroke fill inside different. For example, let's say I want to make circles, but I don't want anything to be inside. They can be like empty. I can do that as well. And for now, we're just going to leave those color values as black. Later on, if we have time, we can come back here and change this. We can add different features that allow us to make any color we want. Okay. So there's different shapes: a circle, a square, a triangle, a hexagon, a star. And depending on the circle shape, we can say that we want to use the draw circle. Draw circle is actually a built-in graphics thing. I have nothing to do with it. It's part of Create.js, right? And actually, it's part of the whole canvas, HTML5 canvas. Create.js enhances the HTML5 canvas API with its own to make drawing on the canvas easier. So there's draw circle, and for drawing a circle you need an X and Y offset plus a radius. That's what you need. And if you hover over that, it tells you that. X and Y offset and a radius. And the next one is draw rectangle. Draw rectangle needs X and Y offset and then a width and a height. Width and the height is going to be the size of the rectangle. A triangle, hexagon, and star uses something called draw polystar. It's interesting. It's like a polygon star. And basically what you do is you pass in how many sides it has. So 3 sides, 6 sides, 5 sides. And then the other option is the the point size. So for example, my point size here is 0. My point size here is 0. My point size here is 0.5, which creates the star pattern. And then the angle of rotation you're going to see here when you make your polystar. And you can look all this stuff up. I've already looked it up for you to create triangles, hexagons, and stars. So whatever you want. And then we're going to end fill. We don't need this part because this is the shape that we talked about before. In our update function, we're just going to basically say, hey, let's take our force and do some physics calculations if we need to, change the velocity and the acceleration based on you know, the stuff that's fed into it. And now it's coming back in French. So first it did the English alert, and now it did the French alert for both for all of us who have different things going on. Okay, so that is our particle. Any questions about our particle object? Okay, so a particle is really just it's not a game object, right? And the reason for it can't be a game object is two things. It's too big, a game object. If I have 500 bitmaps or 500 sprites, it's going to become very, very fat. Okay, so let's try just to draw a particle on the background now. So again, I'm going to go to the background. I'm going to go into my project, and let's test to see if the particle works. So I'm going to go into scenes, and I'm going to go into my start scene. So here's my start scene. And what I want to do is let's just turn off the stuff that's already there. So I don't care about saying this label. I'm not going to instantiate these things, label and ocean. In fact, we're just going to turn them off for now in our scene, right? All we care about right now is the particle system. So we're just going to actually turn off all this stuff. We're just going to comment it out. You can comment back in later, but I want to make room for it so that way you can comment this off. And I did this on purpose like this so I can get the errors, so I know what to comment out. I'll just comment all this out in one big block, right? I probably should have done that earlier. There we go. So that's all commented out, and yeah. Okay, so that's the scene, the start scene. In the start and is where we're going to put everything, but first we're going to make our own public particles, a single particle. So we're going to say that private underscore particle, it's going to be of type objects dot particle. Okay, so that's that. And what we want to do is inside of the particle itself, I'm going to say in start, I'm going to say that this dot underscore particle is equal to a new particle. One thing to note is this stuff. It happens sometimes where you get this stuff at the top where imports. You don't want that to happen. So if you ever get that stuff, just make sure you delete it, or you have some really weird stuff. It's objects.particle is what I want to have. I forgot to put in objects.particle. And it says that I'm looking for 1 to 2 arguments, but I only got 1. Yeah, because objects.particle requires a couple things. It needs the particle shape. So again, it's enums.particle shape dot, and I need some kind of thing. Let's start off with a circle, and then the size. Let's start off with the size of 30, let's say. So size of 30. I also should tell it where to appear. So let's say particle dot x, because we don't have a position for particles. That's going to equal to, let's say, 100, and this dot particle dot y, that's also going to equal to 100. So 100, 100. Okay, so that's the position of the particle. And then what we want to do is down in main, just like we normally do, we just add the particle. So we'll say that this dot add child and this dot underscore particle. All right, so that's how it's going to work. So if everything goes well, we should see a particle that's black, that's a circle, that's with a radius of 30 at 100, 100. If everything goes well, and that's all. We won't say an ocean, we won't say anything else. So going back, if I go back to the page, that's exactly what we see. There's a circle. Okay, are you with me? You should see this too. Excellent. Okay, now let's try some different shapes to show you what I'm talking about here. So let's try, instead of a circle, let's try other shapes. Let's try a hexagon. So let's see what that looks like. So save. You can see that that becomes a hexagon. Let's try something else. Instead of a hexagon, let's try a square. Okay, so that's a square shape. You can see that becomes a square. And let's also try other shapes. So instead of a square, let's try a star. And there's a star shape. And let's try the last one, which is a triangle. All right, so you can see that it offsets it slightly different every single time, but that's what it does. Okay. And by the way, the offset we should probably end up fixing at some point. For now, we're not going to do that. Are you with me? Can you do all those shapes? And if you can, and they're black like this, it's a good start, right? Again, all I've done is I've given you a very simple particle class, and we're just printing it out, right? We're just showing it to the screen. And we're adding it in as a shape. It's different than a bitmap. It's not a bitmap. This is more control for you, right? Computationally, it's a little bit less expensive than drawing a bitmap. Once we create the shape, it literally is a bitmap. It's almost like we're creating a bitmap manually. That's what we're doing, okay? And we're just telling it to fill in with a number of, you know, with this shape, a number of pixels. That's what we're doing here to make this particle. And remember, one thing to note is most, you know, particle systems in real life, they actually happen on the GPU on games, in a game. Here we're doing it, we're making CPU particles because we're not using the GPU right now. In order for us to use the GPU, we could do it, but we'd have to use WebGL, and we're not going to do that here. All we're doing is just making CPU particles. CPU particles means I make it on the CPU and then I manage it on the CPU. GPU particles means I'm making a script, which is a shader, and I manage things on the GPU. I manage things with WebGL, different contexts altogether than what we're using here. Okay, so we're not doing it that way. Okay, so yeah, so we've got this shape. Let's make it so that we've got this. Now let's talk about what a particle system is. Let's get rid of this. That was the particle. So we know particles work. Okay, that's the first thing. And whenever you make your own particle system, you should always check to see, or your particle emitter, you should check to see, can I make a single particle first? If you can't make a single particle, then it doesn't really matter, right? If you make a real complex emitter. Particle is the first building block of what we're doing. Okay, so let's take a look now at the particle emitter. Remember that a particle emitter it holds a series of particles, more than one particle. So right now we have particle emitter.ts. Okay, so particle emitter is a much bigger class, and it's not 100% complete. There's some stuff that's missing from it. And why? Because I typed it out by hand today, and there's a lot of stuff in here. So let's talk about this. Particles is an array of particles. So some kind of list or array, or in C++ it would be a vector of particles. Particle number, how many particles do I have? Emission time, how long do the particles emit? How much time remaining do I have? There's only so much time remaining I have depending on the emission time. What's my rotational velocity? How fast am I rotating everything? What's my emitter offset? Right, as an example, am I offsetting my emitter to the right or to the left? Right? Check my pockets. You know, then there is emission shape. So not only do I have a particle shape, but I also have an emitter shape. So if I go to definition here, you can see that I have several different types of shapes. I can have a circle, so everything gets emitted in a circular pattern, right? I have a rectangle, which everything gets emitted in some kind of square or rectangle pattern, or some kind of arc. This is like where the particles go. That's what it is, and it really describes, you know, how they, you know, what pattern of emission do they have. That's what these three things, these three shapes, and there could be too. But for now, circle, rectangle, and arc are the three particle shapes that we can have, or emitter shapes. So again, we have the particle shape, which is, like we said, a circle, a square, a rectangle, a hexagon, and whatever. And then we have the emission shape, which is all the particles. What's the shape that they emit from the emitter? Like, what is it? A circle, an even circle, a rectangle? What is it, right? And each emitter could have a different emission shape. That's the idea behind that, okay? So now if I go back to my particle emitter, here's my particle emitter again. So we have an emission shape, whatever that is. We have the number of particles per frame. So again, an emission rate could be something like 10, right? And again, I don't have to put anything, so we're going to reconfigure all these later on anyway. I can have, depending on my shape variables, I can have a rectangle size, a circle radius, an arc top, a right arc left. The way we can do an arc is we have 2 points. The left side of the arc and the right side of the arc. These are 2 points on the left and right side. Notice they're both vectors, right? I can also have an arc radius, which is the distance from the emitter origin, right? So that's the way you create your arc. And also the arc angle. In this case, by default, is 30 degrees, right? And then I can have an arc direction, where the way the directions work in Create.js is that 0, which is east, is to the right. And then north, or up, is 90 degrees. And west, or left, is 180. And then south, or down, is 270. That's what it is. So this 90 degrees means its initial direction of the arc is up. That's what it means, up. And then we have some variables. Is it playing? Is it looping? Right, by default it's true. What's my loop delay? My loop delay would be 0. Like, how long does it take before it loops again? My duration, if it's a -1, this means it's going to be infinite. It's going to keep, going on forever. Or you can put a value in here, so it only lasts a second or 2 seconds or whatever, right? I can limit my speed over lifetime. I can limit my my size over lifetime. I can limit my spin or my rotation over lifetime. Okay, that's what these things are. Okay, and then I can decide of my default particle type. My default particle type is going to be a circle. So all of them are circles by default, unless I decide otherwise, right? Then I want to talk about my default position. So my position would be a new vector for my particle itself. The actual particle system is a new position with an x and y coordinate, and I'm binding it to this. So if I change the position, so too does the x and y values of the particle emitter also change. Okay, so we want to use position when we want to change stuff. I have initialized. I'm going to initialize this some value, and we can put for now we can put initialize the particle with 1. Initialize, what it does is it's a public function, and we can talk about how many particles that we have. So we can initialize a number of particles. So in this case, 1. We have 1 particle if you want. When we initialize, we do a couple of things. We free memory. Okay, this is our own function, right? So free memory. Again, I wrote this. So what it says is, hey, if particles exist, if there's a particle array, that's what this is. Is there a particle array? If it is, well, first remove everything from the screen, okay? Then delete the particles, delete the array, set it to null, and set my particle number to 0. So that is freeing memory, okay? And then I build my emitter, build emitter. So I say, how many particles do I want to have in my emitter? So let's say, for example, I want 50 particles, let's just say. So if my particles are greater than 0, then I say, okay, cool. Then my particles is equal to a new empty array. That's what I'm going to do. And then particle number is equal to whatever number I pass in here. So let's say 50. And then I run a for loop, and I say from 0 to 49, I'm going to push back a new particle with a specific particle type. In this case, the default is circle, and with the size of, let's say, 20. So little circles. Okay, that's what it's going to do. So it's going to push back, let's say, 50 little circles into my array. That's what it's going to do. So 50 particles right now, because let's suppose that was the particle number, right? And again, you can vary this. So if I put 50 in here, so let's say I want the particle size, the number of particles to be 50 in my emitter, right? So then that's what would kind of go forth, because then I initialize 50 particles going to the emitter, and we're good to go. The building the emitter. Okay. Time remaining. Remaining is this duration. This duration. So this duration, if you notice, right, is -1. So time remaining then is -1 by default, just the beginning, right? Okay, cool. Let's keep track of that. The rotation is 0, so there's no rotation. I can set my rotational velocity to 0. My emitter offset to 0. So I'm not offsetting my emitter to the left or the right, or up and down. My emission rate is 50, which is 50 particles per frame. Okay. For different shapes for rectangular size, I could specify the size of my rectangle. This is my shape properties if I want to. And playback properties. Is it playing? Yes. Is it looping? Yes. Is from a loop delay perspective, what's the loop delay? 0, right? How about the duration? The duration is -1. We kind of said that already. And then this dot limit speed over lifetime. Well, that's if we're going to set it to true. These are all the properties we're going to set off. We're going to say that we're making an emitter, a custom emitter right here, a default emitter. All right. You can change it afterwards, but I've made one for you, where the limit speed over lifetime is true. I've also limited size over lifetime, changing size so that it starts off with a base size, a beginning size, and these values, which is 20 and 30, that's a range. So I can say like my speed range is between 20 and 30 pixels per frame, as an example, right? My range to between 40 and 50, so it can't go higher than 40 or 50, okay, as an example, my initial speed range. And the same thing goes with ranges beginning and ending. They start at 20 and they go to 30. That's the largest particle that you'll get, 20 to 30 size. And at the end, they'll be between 0.5 and 1, so very, very small particles, if not even invisible. Also, from a mass perspective, we go from 0.5 to 1, okay? And the same thing goes, is spin changing over lifetime? And if it is, then we're going to say that spin begin and spin end, we're going to say is beginning is -1 and end is 1. So basically we're moving from -1 to 1. Okay. Okay, so that is the initialize method. Okay, so we're free memory, we're build emitter. And then what we're going to do is, of course, we need an update function. So we have an update, and in the update we declare delta time being 0.16667, right? We can actually make this a variable if we wanted to. For now, I just put it in there. Rotation is plus equal to the rotational velocity. For now, it starts off at 0, right? And then, now this is where we start to update. We say if this particles exists, so we have a particles array, and the particle emitter is playing, then we say that the emission time plus equals to delta time. So we add emission time. We subtract delta time from time remaining. And if this time remaining is less than 0, and if this duration is greater than 0, so time remaining is less than 0, but the duration is greater than 0, if this is both true, then, which is kind of a weird thing, then what we're going to say is the emission time is set to 0. We're going to say that if this is looping, and if the time remaining is less than the loop delay would be 0, time remaining would be, if it's somehow less, then kill all the particles and remove all the children, and that's what this means. So if somehow the particle is dead, this is the base case. It kind of removes all the particles from the scene and kills the particles, remove the children and all that stuff, okay? And then what we say is, let the number of particles to emit be a multiple of the emission time and the emission rate. Okay, remember the emission rate was 50? What's the emission time? Well, let's go back up and see, right? Emission time, we're saying that it's going to equal to delta time, right? By default. Okay, cool. So that's the number of particles to emit every frame, right? And then we're going to say for each particle inside the particles array, if the particle life is less than or equal to 0, and the particles to emit is greater than 0, so we haven't, in other words, if the particle is inactive, that's what this means, and there's particles to emit that's greater than 0, then let's spawn a particle. All right, that's what this means, spawn a particle, right? When we spawn a particle, we subtract it from the number of particles to emit, and we subtract emission time. Okay, so we subtract emission time from 1 over this times emission rate, which is going to give us an emission time. We update the particle, and we're going to see what update particle does, and that's if its particle is inactive already. If the particle is inactive and then there's a particle to emit. However, if the particle is active, then just update it. That's all it means. That's all this thing does. So that's the update function. Let's take a look at the two things it does: spawn particle and update particle. So spawn particle, it says, okay, well, we have a particle to spawn. Our particle lifespan is equal to a math lerp, and the way it's done is from a life range of x to a life range of y with some random value. Remember, the random value, when I go math.random, gives me a value between 0 and 1. And that's our t-value. Our t-value is, if it's 0, then when we do a lerp, which is a linear interpolation, it starts closer to the x value. If it's 0, it's right on top of the x value, actually. And if it's 1, if math.random produces a 1 or something close to 1, then it'll be closer to the y value, which means our life range is between whatever the life range is and the maximum life range, a min and a max. That's what these x and y values are, right? And then we said that the particle life is equal to the particle lifespan, this particle lifespan here. And we keep doing that for all the different options. And I've defined so far rectangle and circle. I didn't finish defining arc. We didn't finish doing that. There's actually another section I have to type in. I'm not going to do that right now today. I just want to make this simple particle emitter work for you guys, okay? And then afterwards, I set up the start speed. Here's my start speed. And it's a random range between the initial speed range and the initial speed range y, a minimum and a maximum again. Set the velocity on the x and y to the start speed. And we're going to set the speed limit, begin and end. And finally, we're going to add, the particle size is going to be the size begin, whatever the beginning size is. And we're going to add the particle to this container. So the container is going to be the particle emitter. Because remember, the particle emitter itself is a create.js container object, similar to a scene. That's what it is, right? Okay. And if you haven't get confused yet, and if it's and if you're good to go, that's what our spawn particle does. So spawn particle. Let's just go, not to initialize, but let's go to spawn particle. So I want to go to, you can do this here with create.js, sorry, with Visual Studio Code. I can just click on something I want to see. I can just go to that right there, just by these little breadcrumbs up here. These are links you can look at and create in Visual Studio Code. Okay, so here what I'm doing is I'm testing out the different emission shape. Like I said, I've defined rectangle and circle, and then what I'm doing is I add the particle to the stage. Cool. Then I have update particle. So remember that I do two things. I spawn a particle and then I update the particle. And if I go to update particle says, okay, cool. Well, give me a delta time, right? Whatever that is, 0.116166667, right? And then if my particle.lifespan, if not my particle.lifespan, if I don't have a lifespan, then particle lifespan is equal to 1. Okay, so give it a lifespan, right? That's what update particle does. And I'm going to create something called normalized life, which is a clamped value between 1 minus the particle life over the particle lifespan. It gives you a normal, right? That's what it does, 1 over, 1 minus. And then that is the value that I want to clamp between 0 and 1. So basically, a normalized life means life starts at 0 seconds to 1, 0 to 1. And then I check to see, well, is size changing over lifetime? If there is, then lerp between the beginning and ending size. Is speed limit changing over lifetime? If it is, then go from one speed to the other. How about is spin changing over lifetime? If it is, then go from the beginning speed to the end speed, and so on, right? And what about rotation? And then finally, I move my particle. I said that the particle x and particle y plus equals to the particle velocity.x times delta time. So I'm moving the particle according to its velocity. That's what I'm doing here. And then I subtract delta time from particle life. So as I move it, it starts to die. That's what's happening, right? If this emission shape is a circle, by chance, then I want to calculate the distance between 0 and the particle x and y. That's what it's going to do. A new vector for a particle x and y. And if that distance, if the distance between that is greater than or equal to the circle radius, then I want to say that it's left the circle, then I want to make my particle life 0. And the same thing goes with the arc, which we haven't defined. If the arc leaves the arc radius, then it dies as well. Okay? And then I update each particle. Each particle is going to go through the update process. Whew, and that is my particle emitter. So we have quite a bit of complexity. Let's test out the particle emitter now and see if it works. And again, the great way to do that would be to instantiate a new particle and do some troubleshooting. A new particle emitter, I mean. So this is the real test, right? The first part of the test was, hey, can I make a particle? And we proved that yes, indeed, we can make a particle. The second part of the particle is, okay, cool. Now that we have a particle, how do I make a particle system? How do I do that? And you know, what does that look like in fact, right? So yeah, so that's what it's going to look like. We want this new particle system to be in play that allows us to you know, to kind of show a particle system. And if you bear with me a second, I just want to check my code to make sure that I've got everything on the go. All right, so I want a new particle emitter. So let's do that first. So I'm going to go back to the start scene here. Okay, here's my start scene. And instead of just a simple particle, I'm just going to make a particle emitter. So I'm going to say that private underscore particle emitter, right, is of type objects dot particle emitter, particle emitter. Make sure that somehow nothing got updated up there, please. Because sometimes what happens if you put the wrong thing, it'll do a require, which we don't want. So this is the first part. Do we have a particle emitter? Yes. Excellent. Okay, the next part. We want to instantiate the particle emitter. Okay? We want to instantiate the particle emitter. And we also want to say that the particle emitter is playing. Okay, so we want to make sure once we instantiate the object that the particle emitter is playing. Okay, that's the kind of stuff that we want. So let's do this thing. So again, here's my particle emitter, and down inside of the start function, which is here, just like we did before, I'm going to say that this dot particle emitter, right, is equal to a new objects dot particle emitter, and I'm going to pass in nothing. It doesn't take anything right now. Okay, but what I can do is I can configure it. I can say that, well, this dot underscore particle emitter dot, and you can see that I have several things. The number of particles. So number of particles, or particle number is what we call it. Particle number is going to be equal to a set amount. So we can start off as an example where particle is equal to 1. So we want to have 1 particle, just by chance. And then I can set up the particle type. So let's try this. So I can say this dot underscore particle emitter dot particle type. We can set that up here. And that is equal to, again, notice that particle type is of type enums.particle shape. All right, by default it's a circle. So let's make it a hexagon in this case. So particle type is equal to enums.particle shape dot hexagon. So I want to make it a hexagon type, right? And by the way, it says that particle type is not allowed to be put into particle shaped circle. So what did I do wrong? So particle emitter, particle type, I made it enums.particle shaped circle, which doesn't make any sense. Actually, it's wrong, right? So let's go back and fix that. Let's go to definition. That's actually my bad, right? So it's not. It shouldn't be this. It should be enums.particle shape. That like this. That's how it should be. So please change that on line 49. That was an error in my typing today. Okay, so cool. So then I can assign it to a hexagon. That's the first thing. So now my hexagon is particle shape number 3. Okay. I can set my position. So let's set my position to the middle of the screen. So I can say that this dot underscore, and there's some things that I can put in here to help me. This dot particle emitter dot position again is equal to a new objects dot vector to object, where I can take in x and y coordinates or a whole new vector too. So an example here would be just x and y coordinates. I can put in like again it's 640 by 40, so 320. Let's put it in the middle of the screen, and then by 240. Let's see, start with that for now. Actually, start it a little lower, so it's not exactly in the middle. 300, let's say. Okay. So my particle type is that. Okay. And then what I want to do is I want to define the number of particles. So I start off with 1 as an example, and we can start off with more. I'm just thinking about the emitter shape. We have to define the emitter shape and some other stuff. So let's think about the emitter shape. So if I say instead of particle number 1, let's make particles number 50. Okay, just to do that, and we can say that this dot underscore particle emitter dot emitter shape. So I want to kind of define the shape. And what would that be? See, this is the problem with this emitter shape. Yeah, we're going to make little setters for this in a second, right? I'm just, again, at the beginning, all we want to do is we want to think about emission shape is what it is, not emission, not emitter shape. Okay, so emission shape. Emission shape. We'll say that the emission shape by default is a enums dot emission shape dot. We'll make it a circle. All right. So the default is a circle. So hexagons. It's a circle. Yay! Awesome. And that's the emitter shape. And we can also talk about the size. Right, how big the emitter is. So right now there's a default, but let's set it up. So we can say this dot underscore particle emitter dot. We want to set the size, if you will, and this is the circle size. That's what we want to do. So we want to set up the almost like the width and the height. So I want to set like the rectangle size more than anything else. So rectangle size, and that's really a think about it as a bounding box or a bounding area, right? And we can change these later to make more sense of them, right? New objects dot vector to object. Let's make the bounding area 100 by 100. So let's make it 200 by 200. 200 by 200. All right, so that's the size of my bounding area, all right, for my my size, if you will. Okay. Cool. So that basically creates my emitter in a very I also want to talk about the circle radius. We have to also have the circle radius just in case. I think maybe the circle radius is important too. Particle emitter dot circle radius. We're going to say that that is 200. 100. 200 would be too big. So circle radius, rectangle size, which is the bounding box, and I think we've got everything we need here. And we want to call on update. We want to call the particle emitter update. So this underscore particle emitter dot update with a U. Right. So this will update the particle emitter every frame and all the particles inside of it. Whatever particles are alive, anyway. That's what's going to happen here. Okay. Okay. So this is good. So I've got all this stuff, and I want to add child the particle emitter to the stage, right? So down here, I'm going to say that this dot underscore. So this dot add child first of all, and then this dot underscore particle emitter is what I want to add to the stage. So this is going to add the particle emitter to the stage. And now you can see that there's nothing on the screen, and this is where we have to do some troubleshooting, right? Because we have to figure out like why it's not showing anything, and this is kind of some of the things that we want to do right now. So if I go to console, you can see that I got no errors. That's not the issue here. It's not that there's an issue with errors. It's just that there's nothing showing. So we need to do some tracking and see what's going on here. All right. So one of the things to do is before I add everything to the stage, I want to check to see, hey, what what's going on over here? Is there something that's missing? Do I have to do something else, you know, to make this work? Because again, what we want to try and do is think about what all is happening. So I set up a particle, I set up the position, I started things going, the particle types I defined, the shape, the radius, the width, and the height of my rectangle. All those things are good, right? And I just want to make sure that I have everything I need here to make sure that we go, yeah. And then I need to make sure that it's playing. So I'm going to say that I want to turn it on. So I'm going to say that this dot underscore that particle emitter dot is playing. Well, that is definitely true. I want to make sure that it plays. Okay, so that's going to turn on the particle emitter. If I don't have this, then there's a higher possibility that it's not going to work at all, right? So that's the part that I need to do. So that's this part. So we know it's playing. We know it's playing. We know the particle emitter is moving and all that stuff. That's the way it should be. Now, let's do some troubleshooting to find out what's happening, because we know the particle works. It's not about the particle. It's about the emitter. All right, so let's just, what I'm going to do is I'm going to make, it's a trick that I usually use. I kind of put together a console log, and this dot underscore particle emitter, I want to kind of print out the particle emitter. That's what I want to do first. So first, let's print this out and see what I get. All right, so again, I play, I refresh. Sometimes you have to also refresh to make sure that that's working, because that should be something that I see. And then I see that there's a particle emitter here. And so I can start inspecting the particle emitter here in the on the stage. So I can see that a couple things. I have my scale X and scale Y. So this is bad. X and Y coordinates for my particle emitter are 0, 0. All right, so that's my X and Y. So my position didn't quite take effect. So wherever I set up my particle emitter, that 0, 0 is a negative sign. So particle emitter should be whatever I set it to. And unfortunately, it didn't do that. Right, so that's one. And I can look at my components. So here's my children. Notice that the children were loaded. So there's like 50 particles that were loaded. So this worked. So I loaded my 50 particles. And I can look at each of the particles, and I can see that where the X and Y coordinates are, right, as an example. These are the X and Y coordinates. And you see that there's different X and Y coordinates on the screen. And I have a mass, and a life, and a size. These are all things that kind of happened, right, when I took stock of the particles to start with. Same thing goes with all this. So the actual particles are there, right? It's not like they're not there. They're physically visible, or they're physical there, but they're not visible for whatever reason. So that's part of it. Remember that the X and Y coordinates of each of these particles, each of these children, are relative to the position of the particle emitter. All right, so again, it doesn't matter which one I look at. Let's look at 39 as an example. And if I look at 39, you can see that the X and Y coordinates are different, because they're going to go spiral in a different position starting off, right? So this all works. This is all good. You can see that the stroke and for each of the graphics of each of these things is 0. We know all these particles work, so that's not the issue. The issue is not the particle. The issue is the emitter, right? Emission time and emission time remaining, you can see that that's something that's really weird. -50, that's a really weird thing. Emission rate and circle radius are arc radius, arc angle, arc direction. These are all things that I have. Is playing, is looping, loop delay, duration. All this stuff is all good. Initial speed limit range. We have variables for all this in terms of our stuff. And here's our position. So the position went through at 320 by 300, but you can see that the X and Y coordinate for these in our vector did not function somehow, right? So that's interesting. So that's something that failed for us, right? That the X and Y coordinate of our emitter didn't really take. Okay, so that means that, I'm just putting it out there for you, right? That one of the challenges that we had with this thing is that the vector didn't work somehow. And to show you this, we set the position as 300 and 200, 320 and 300, that worked, but the x and y coordinates itself didn't change. Let's go do it manually. So x is equal to 320, and this dot underscore particle emitter dot y, well, that's going to be equal to 300, and that will reset those things where they're supposed to be, right? So let's just refresh. And again, we don't see anything, but that's because it could be this just paused. So again, let's inspect. And then we're going to go into it. So this is my particle emitter now. And you can see that, yes, indeed, they did go through 320 and 300. So that's good. And we still have our children. That all works still. Those are all good things. Okay. So we know that they're there. Okay. We know that they're there. All right, let's do some other troubleshooting. So let's now run through the system. So here we create this. Now, why didn't the position work? So when I set position, let's go back to the particle emitter and see what happened here. So when I said that position is equal to objects.vector and I'm passing in this, then anytime I update the position, when I set the position, right, then so too does the position, would the position change. And we've kind of done this before with the other objects. For example, plane. So here's our plane, right? And plane, we say that the position is equal to new position. That all works, right? Why? Because it's a game object. So in game object, we say that, hey, we have a bunch of objects. We also have a position, which is a vector 2, which we kind of did. And we say that whenever I set position, let's take a look at set position here. Because we have a bunch of setters, right? We have getters, and we have set types, and we can have is centered. We can check all this stuff, and is velocity, and then here's position. Position is just this position. Oh, but this is the part that we're missing. This set position. So this would be a great thing to put into our other function, our emitter. It's not a, remember, emitter is not a game object, but we want to be able to do this kind of stuff. So let's just grab all this. We know this is a bug anyway, even though we still don't see anything. And let's fix our emitter. So let's go back to our particle emitter. We can still do this, right? This part. But what we want to do is also put together a getter and setter for our position. So we'll use that from now on. So we can kill two birds with one stone. We'll say that position, right? And we'll say this as, we'll just call this underscore position for now, right? So this underscore position is equal to this, right? And then we're going to set up our position as a new position. Okay, so now remember, this is public for now, all right? So if you want to set this up properly, this would be private. Private, we can cut this out here and put it up here in private instance variables. This is the first property we're going to make as private. Okay, there we go. So that's the position. And so we have a getter and setter for this now. And anywhere else, if I search for position, just position by itself, we can see where it's referenced. So let's go down. So we see that there is several positions there. And, do we reference position anywhere else? And the answer is no. Not from inside the particle emitter. Okay? The particle emitter itself, the position is not rendered. It's only externally to the particle emitter. All right, so that's cool. So that's the first step. So, yay. Okay, excellent. So that's the particle emitter itself. So then in the start function, we can now go back to what we had before, which is particle emitter dot set position dot set position, or is it just position, right? Well, that's just equal to a new objects dot vector to object, where we can say that that's 320 by 300, let's say. Okay, and then when we inspect the position again, this console, the emitter, we should be able to see. I'm just going to refresh here. We should be able to see in the console that we got a position for our emitter of 320 by 300. There it is. So there's our X and Y location plus we have a position variable that's also 320 by 300. There it is right here. Okay, so this is important to look at, 320 by 300. Cool, so we know that that is true, okay? That is true, okay? So emission rate is 50 and circle radius is 100, and we know that this is true. This is all good. Is playing is true, and all that stuff. Now, next, now that we know that we have a basic position established, let's see why we haven't had any particles so far. So the other way to do this now, next step, is to actually add some breakpoints, and we talked about this before. So more of a troubleshooting, exercise. I'm going to put a breakpoint right here on the console log, which means I'm going to be able to inspect the emitter in more detail and kind of run through it a little bit, okay, which is what I want to do. So let's first start with this, and in order for me to breakpoint, I'm going to go into this run, and you can see that I have this thing that says launch Chrome. I can do that, so launch Chrome. Cool, so as soon as it goes, it opens up and it gets this console log, and now I have some information. Okay, I have some information. So here's my local, this dot starts. Okay. Here's my call stack. So I went to start, and then I went to main, start, which is the start function, and then I went start main, and that's our call start. Okay, call stack. We have one breakpoint. Okay, we don't have any exceptions, but this is all the details, the data that we have for everything that's inside of our start. So we have properties, we have our alpha, transparency, we have children. We should have an array of one child, which is the particle emitter. There it is right here. And you can see that the particle emitter, if I go through it, right, has all these variables, emission rate, and so on. The thing that's troubling to me, right, the thing that's troubling to me is that the delta time and all that stuff is weird. Like the emission time, emission rate. And the beginning, when I first looked at it, I was like, wait, something's wrong there, right? So that's one thing. And then the other thing is, I want to make a, I can stop this. So I definitely want I can make a breakpoint there. But I want to also look at the update function of my emitter. So if I look at the particle emitter itself, and in the update function, right, or in the initializer, I want to go all the way down to where it says, to this part right here, to where it says spin ranged end. This is the initializer, or in the so I build my emitter. That's what it does, right? So remember, in the init function, I do a couple things. I free my memory, I build my emitter, my time remaining is this weird thing, right? And then as I go through, I set up all this stuff, and this happens for everything. So it doesn't matter what I pass in here or not. Even if I set it up again, it's going to go through here and basically go and do this again, right? In my initialize, right? So initialize sets up basic things, the emission rate and so on. Okay, that's what it does. Is loop playing? It's true. It's going to play. Is looping? Yes, it's true. Is loop delay 0 and duration is -1? These are all things that we talked about before. So then, free memory, what it does is remove stuff, and build emitter we know works because it built all kinds of stuff. But here in the update function and in the spawn spawn particle, right? I want to see when when this thing is actually gone. So do I actually spawn a particle ever, right? And this spawn particle actually does, it spawns a particle, and then what happens is somewhere this spawn particle method, right, is going to add child at, and this part right here is what I want to stop to. So those two little points. So when I add child at, and when I go to the spawn particle. Let's see if that works now when I go to this. So do I ever get here is what I'm going to try and say. Okay, so let's try that first. So again, I'm going to go in here and then launch, and then do I get to that point? And I do, right? So you know it's gone here, right? So here's my spawn particle, right? let's take a look at it. We can inspect the particle. So this is a great thing. So once I have a particle, I can look at for each particle. It's this one. And I can see that this has a life of 0 and a mass of 1. It's got a scale of 0. The size is 20, so I made it the right size. Here's my velocity, and the x and y coordinate relative to the entire thing is 0. Okay, that's what this happens, right? And now we can step through it. So number of particles right now, if I look at the number of particles to emit, so if I want to look at this thing, so here's my particle. So what is the number of particles to emit? This number right here, right? Number of particles to emit. So how do I inspect that? So let's put another breakpoint right here. Let's actually do that and rejig it. Okay, cool. So now let's look at this for a second. So this, it says, is undefined. Well, that's okay. But my challenge is it goes through here, right? And here's my variables. Okay, so particle emission, delta time is 0.166. Number of particles to emit is 8.335. Okay, that's the number that I'm going to emit this frame. 8 particles. Okay, number of particles to emit. Okay, and then you can see that. I'm just going to go through the closures here. There's my object, my vector 2. And here's my globals. I got a lot of globals here. I don't want to see those. But basically this stuff here, this first closure, which is the particle emitter, right? Delta time in this particular place, and so on. Okay, so let's stop this then. Stop this, and let's take this off and go back to here and start it again. Again, I'm going through one time. So starting off, blah, blah. Here you can see that the particles to emit is 8.335, again, based on the emission rate. Okay, and then let's just step it through. So again, I'm going to step over. So okay, so it says, when I'm down here, it says my random angle is 3.9 degrees. That's what it is. My random speed is 1.21. That's pixels, right? And my random t-value is 0.39. These are all good. Start speed is 29 pixels per frame. That's what this is. And position, look at that. Position is undefined. Should position be undefined? Let's take a look at that. So where is pause? Here. All right, so, but the reason why it's undefined is because it never went in here. Because it never went into this part, right? Because position is not a rectangle. Position, because the emission shape is a circle, it skipped this entire thing, this part. And that's why position was undefined. So we should really know random angle, which we do, a random speed, a random direction, and direction x and y, which we have for cos. So the direction itself, the direction vector, if you will, should give you information about where it's going. Okay, so that is on the x-axis and on the y-axis. So it's minus 25, minus 25. So for people who know, where is that going? Minus 25. Well, it's going to the left and up. That's the direction of my first particle. My first particle is going to the left and up. Okay? If that makes any sense. Okay? Left and up. Okay, then I set the particle velocity. Particle velocity, so which is the velocity itself, right, is now equal to the direction. So basically I take this negative 25, and that's the particle velocity. Okay, excellente. So that's the first part. So then, after I've got the particle velocity, I come down to here. I say start speed. All right, so start speed is 29. And why? Because I take the initial speed range, which is 20, and it goes from 20 to 30. I get a random number. And now my particle velocity dot x, right, is going to be equal to multiplied by my start speed. So my start speed is 29, and then multiplied by x, which is minus 25. So now it's more negative. It's like way out there, like far out, right? That's per frame, guys. That's really far per frame. So it's kind of a really big, number that we're getting, right? Because that's what it's going to be. So then I have this number, whatever, start speed, and I get this value, minus 25. then my particle speed limit is, it begins at 50 and it ends at 42. So it actually gets slower. So the speed limit end is 42. Okay, so that's the beginning and end, or a range, speed limit range, right? My particle size is 23. That's the size of my particle, because remember that I have a size range. I start around 20 pixels. There's going to be some bigger ones and some smaller ones. Okay, and then I add child at this particle. So it actually got added, right? This thing got actually added in there. Okay. Okay, and it says add child this particle. Add this particle to this to the particle emitter. That's what this does. Okay. Remember, the particle is a shape. That's what it is. So it's gonna, when you add it to the stage, right? And I add the particle emitter to the stage, then everything gets added to the stage. Okay, so that's what happens with my add child at. Let's continue. So then I step through, it goes back, and now I have a second particle. So this is particle number 2. Right, let's just do a couple of them, okay? So particle number 2, right? Particle life is a different value. Number of particles to emit is still the same amount, okay? Now we can see that what they are. Particles to emit is 8.335. 8 particles per frame basically is what's happening here, right? That's my emission rate, more or less, right? And then let's keep scrolling through. Let's go to the next one. So again, number of particles to emit. I've got that number, 7.335. That's the new value. And then go to the next one, emission time, right? And what is my emission time? Emission time is minus equal 1 divided by the emission rate, right? That's what that does. Okay, and then I have update particle. Let's step through that. And then boom. Okay, so we update the particle, and then when it updated the particle, right? And this is interesting. What's happened is it skipped through, right? Look what it did. It went particle, and then it came back to here, and now it's going to go back up again. Let's go back up. Okay, cool. We get another particle. We spawn the particle, right? And then as we spawn the particle, we add the particle to the stage. Here's the random angle. Here's the random speed. Here's the start speed, 27. That's the amount we're going to add. And then we add it to the stage, right, as an example. And then we keep going. We go here as an example, another particle, right? And then we keep going. And we keep going through this process over and over again, right, for each particle. And you can see what happens is this is totally working the way it should. 5 particles, look at number to emit, 5, 4, 3. And it keeps going down lower and lower and lower, right? Until 4, number of particles to emit, 4. 3, 2, 1, and then I'm just stepping through it all the time. 0. So I don't have any more particles to emit. Okay, and I keep going. Uh-oh, what the heck is going on? Number of particles to emit. Well, number of particles to emit is negative, right? So remember, if only time it does this if number of particles to emit is greater than 0, right? Which means we should exit out of here now. Okay, so it goes here and it skips. Now we don't have new particles to emit. We've emitted all the particles, and now we should just be in this part, right? Take a look. It goes here, and let's step into this one, this process. So it steps in, and it says if not particles lifespan, right? If not particles lifespan, when we're into this closure right here, right? So, okay, and let's keep going. So skip over that one. It goes in there. My lifespan is now 1. So if my particle lifespan doesn't have a lifespan, give it a lifespan. Cool. And then normalized life. It calculates normalized life. Normalized life is actually a value is 1 right now. Okay. And so it's doing the things it's supposed to do. Speed over lifetime, if it's true, yes it is. Give me a speed, that's what this is saying. So now, this is interesting. It says that the speed is not a number. The speed is not a number. Why is that? Look at my rotation. So my delta time is 0.66. And this is where we have to check. This is what I'm doing. I'm checking to see what it is. So particle speed limit begin is undefined, guys. This is where we're having an issue. Speed limit begin is undefined. Right? We don't have a beginning speed. We don't have any of these things. We haven't defined any of this stuff somehow. Well, how's that possible? Because didn't we define this somewhere else? Speed limit begin and end? We did, basics, right? Speed limit begin. But now we're seeing that there's some problems. Speed limit end, also undefined. Normalized life is 1, right? And what about our size begin? Size begin is undefined. Size end, undefined. If I have a size end is undefined, look at, then my size is undefined, and then so far, so is my particle size. That's undefined. Particle size is undefined. Well, we're not going to see anything. So something is wrong here. We just caught it. This is the place where it's got a problem, because it's going through and we have issues for each of the particles, right? Each of the particles, those don't really have a value for speed limit begin and speed limit end. We don't have that. So when we go through here, we put up a particle, but unfortunately what happens is we don't have values for those things. We don't have values for the particle itself. So up here, where we said that the beginning particle speed limit and everything else is there, this is good. This has happened. This is where it gets updated, right? Unfortunately, what happens is for each particle that's going to be updated, for at least for this time, we don't have any values, right? So even though this has been calculated and we have a value that goes here, here is undefined. Look, speed limit begin, and why? It says random range. Okay, so util math, random range, this is where the functions break down, and when it go from 40 to 50, 40 to 50, and the random range, we're getting a value of undefined. How's that possible? Okay, let's stop. Let's stop right here. So let's see what let's print out some speed limit ranges. Let's do some of this stuff now. In order for us to. So this is a great troubleshooting exercise for you guys, because you guys have sometimes very complex stuff. And let's print out some. This is for each. We'll do a couple of particles. Okay, so we'll say console log. We want to do too many of these. So we'll say particle dot speed limit begin. All right, and we want to kind of print out that, because it'll print out both the x and the y axis. Because remember, speed limit begin is actually a number, right? So we'll say particle speed begin, speed limit begin. We don't want to see it undefined, okay? Plus this. And if we do, we can start tracking what's happening, right? And then particle speed limit ends. We want to see what those values are. Okay, and we also want to have the particle size. I want to know what that is. So let's grab one of these. Because we can't, adding a child and we have no speed limit, then what's going to happen is then the particle is going to be dead, right? It's not going to show at all, right? We also can probably show the velocity and all that stuff too. Velocity, we can show that off as well. In fact, what if I really want to do this, I can just console log the particle itself. So, but let's do this first. Let's do the particle size, and then this is be the particle dot size. So let's see what I get there with just those two. Now we'll have a lot of particles. We have 50 particles. We can break it down to lower amounts. In fact, let's do that. Let's make it so that all we see is 1. So again, if I go up to this, I want 1 particle, just 1. Okay, that's what this is saying. So that's my emitter. Particle emitter is 1. And the same thing goes with my particle emitter. Let's go in here, and instead of making like a default of like 50 or something in the constructor value, let's just put 1. Okay, so let's just do that first and see what I get. So again, let's just run it. So save that, and then go to our thing here and refresh, and let's see what I get in the console. Right? We should get one particle, and we should see values. Okay, so well, this is good. So we're looking at values of my particle. You can see that the size, it keeps changing because it keeps being emitted. The speed limit is 42 and 50. The size keeps going up and down, so it keeps on looping. This is what's happening here. So it's actually working. We just can't see it for whatever reason. Okay. Okay, so these are good things, and this is what should be happening. Okay. It's definitely good that we're seeing those values, because at the end of the day, if we don't see values for in our update, that's bad. Let's also do a couple other things before we add it in. So we'll say console.log. I want to see the particle position, so I'll say particle position, right? And that's going to equal to the particle.position. So particle.x. So we'll say that. We'll say particle x, and we'll do the same thing for particle.y. Let's see where that is. Like, is it off screen still? Like, where is that thing? Remember, this is relative to the emitter. That's what's happening too, relative to the emitter. All right, so cool, inspect. We should see a bunch of particles. Okay, well, particle is at 0, 0. Okay. Well, 0, 0 should be at the emitter, which is at 320 by 240. That's weird, right? Because our particle x and y should be something that's being modified every frame. Now, we can't see it, but what's happening is that it should be like just here, like bubbling in here, like just showing us a black hexagon, as an example, right in the middle somewhere. But particle x and y seems to be 0 the entire time. And that's right here in this. We can also try and just add child. Instead of add child at, we can just add child the particle. So let's add child the particle and see if that makes a difference. So console. I still don't see anything. Let's make sure we refresh. Sometimes we need to refresh 1 or 2 times, right? So that's definitely add child. The particle is being added. Now, where is the emitter? So if the emitter is somewhere off screen, that's a problem. Okay. I mean, it is working. Look, you can see that there's something going on. The x and y coordinates are troubling, but that means we just should see everything in the middle, like physically, right? It shouldn't be 0, 0. And even if there were, we would see it at the top left corner of the screen, which we don't. Okay. So that's interesting. What else could we do to understand some stuff, right? So we've done some troubleshooting. We know that we're getting some weird ranges. This is what's happening when we, we call spawn particle. Spawn particle becomes spawned, right? And we spawn particles in a bunch of ways, and then we update the particle in here. So let's take some of this information. We know this is happening, right? This stuff. Sorry. And we want to get this, what's happening for each particle. So for each particle, we're going through, and we're getting down to the end here, and let's see what it does down here. So this is for each particle. For each particle, we're just doing this, right? So let's see what we get down here. So what's the x and y coordinates after we do a particle update? Okay. Okay, now we're getting wild values. All right, and this is good, right? Again, because we're looking at, look, negative values, negative ones, it's moving, and it looks like there's a range. Look, it's not going beyond a certain range. So the x and y coordinates are going to be relative to where it is. So this is working pretty good, actually. Look, it's just not printing out the object. And this is for one particle. So one particle is streaming in different directions. Okay, so it's on, it's moving, we just can't see it. Okay? I don't know why I can't see it, but we can't. All right, next. We don't need particle size x and y here anymore, because that's confusing. How about the speed limit begin and end? Let's take this part and put it near the bottom too. So we'll say, hey, after the particle's been updated, what is the speed limit beginning and ending? So we know before we were having undefined. So let's see what we're getting now. So again, going into inspect. Okay, look, here's our speed limits, 42, 45. So maximum we're getting is like, 45 or whatever. So it looks like we're pretty good. Like it's going from a range of 40 to 50, exactly what we thought it was going to be, right? And you can see that some of the ranges are going to be negative, some of them are going to be positive, but still they're inside the same range as they were before. Okay, so we have the particle, and it's only for one particle we're looking at right now. It's the same particle. It's just going to be regenerated every single time. Okay. Okay, so it's happening. I'm happy it's actually updating. It's just not showing, right? For some reason, right? It's not showing, and there could be a lot of reasons for this, right? But the main one that I think is it's this one, this dot add child particle, right? This dot add child particle. So it's just not. This container is not showing up. So one way of testing this is to make a simple particle by itself, and when in the constructor value, we just make a single particle that just hangs out in the middle of the screen. So we'll say, like, we'll make a particle, let particle equal to a new objects dot particle, right? So we make a new particle, right? And objects dot particle requires a particle shape by default. So we'll say that enums dot particle shape dot, we'll make it this time, just make it different, a circle. So a circle shape, right? And we'll define the particle itself. We'll say the particle dot x is equal to this dot x, and particle dot y is equal to this dot y, right? And then we'll add the particle to the scene. So this dot add child, and we'll say particle. All right, so that should, yeah, there it is, right? So you can see that that works, that it actually, when we say this dot add child particle, it adds a child to the particle emitter, and the particle emitter is being added into the stage, so this actually works. Okay, what about if it was a hexagon? We're having a problem with that. Is that what the problem is? Nope. That works fine. So we know this, so the particle actually works through this thing, no problem. Okay, it works through this thing. Maybe it's just dying too quickly. So let's step through this again to look at this. And guys, what I'm going to do is let's take a short break. But learnings for this session. Why am I showing you all this? Right? Is the idea that when you create a particle system, it can be very complex, right? And we're starting off with some building blocks. We're starting off with a particle emitter. We're starting off with a particle and a very simple particle emitter. We're trying to make it so it shows stuff on the screen, and we've worked it out so that we see movement physically, but we're not actually seeing the actual object, which means somehow the object isn't being added to the stage, or what's happening is it's being added to the stage and yet removed immediately. One of those two things. Okay, so it might be too quick for us to actually see, which is what's something that might be happening. Okay, so let's get back. I'm just going to stop recording now. We'll take a short break. Let's say we'll take 15 minutes and we'll come back, and then hopefully we'll have this ready to go for you. Okay, and in the meantime, are there any questions before we move on? I'm looking at the thing. You guys are all good? Again, just a reminder for those people that are still around, and thank you for sticking around. I know that this is a tough one, but for those people sticking around, remember that Sunday is our assignment number 2 to do. So please work diligently to get number 2 done. Okay, so I'm going to stop recording right now, and then I'll take a few questions, and I'll take a short break. So let's just tear this off and stop recording.